You're listening to Autumn on the Air, the weekly podcast that brings you conversations about the impact of research commercialization and the people who make it happen. Join us for interviews with patent and licensing professionals, innovators, entrepreneurs, and tech transfer leaders on the issues and trends that matter most. Keep listening for an inside track on the people, IP policies, and politics changing our world.
Welcome to Autumn on the Air. Today we'll be diving into a two-part series on the history of tech transfer. In this episode, we'll be exploring the origins of university tech transfer offices and the story of the first such office established at the University of Wisconsin-Madison, the Wisconsin Alumni Research Foundation, also known as WARF. Joining us is Kevin Walters, a historian and expert on the topic, who will be sharing his insights on the early patenting efforts by universities and how WARF came to be. Kevin works in public affairs at WARF, where he has served as a researcher, historian, archivist, and executive communicator since 2011. He grew up in Central Texas and earned a BA at the University of Texas at Austin. He went on to complete 2 MAs in history and humanities from the University of Texas at Dallas, while working as an operations and scheduling analyst for GE Consumer Finance, which is now Synchrony Financial. Kevin moved north in 2010 to earn a Ph.D. from the University of Wisconsin in Madison, with a focus on the early intellectual history of university patenting. And it's that research he's here to tell us about today. Hi, Kevin. Thanks so much for joining me today on the podcast.
And thanks for having me, Lisa.
Yeah, I'm really excited to have you on today, Kevin. And I know you have a BA in humanities and history, as well as an MA and PhD in history. So can you tell me a little bit how you ended up in technology transfer and at WARF?
Sure. I think I've listened enough of your podcast to know that this is something of a common story, that not a lot of people grow up wanting to get into tech transfer. So it's something that we fall into. I think it's also a profession for people who keep swimming, who just sort of find their lane. And that was my case. I had a pretty interdisciplinary background, I would say. I ended up landing in history, but was kind of going through different things of, art, history, philosophy, different humanities kinds of things, but they all were humanities degrees. And eventually I settled on history, applied to a history PhD program, and ended up in Wisconsin, applied to a bunch of different places. I grew up in Texas and moved here for grad school. And at the end of my first year, my PhD program, I needed a summer job. And at the time, probably still the case that humanities grad students are always looking for a little bit of extra money. And I needed just some summer spending money. And my advisor happened to know the director of WARF and knew that he was looking for somebody to look into their history a little bit. And he connected me with him. And the director of WARF basically just said, here's 3 boxes from our archives. Take a look at them at the end of summer. Tell me what you found, which was kind of a historian's dream of just here's the sources that nobody else has looked at. Maybe not nobody, but certainly they were underappreciated sources that I got to look at fresh. And I gave a presentation to the Board of Trustees at the end of the summer, and he said it was good enough for him to keep me around on an hourly basis. So I kind of kept coming into WARF. And then one day I got this text from, I guess it was an email. I always think back, if I had not had a smartphone, would my career have turned out entirely differently? But I was at home, I was about to bike into WARF, and it was around lunchtime because I'd been a grad student in the morning, was going to go work in the afternoon at WARF for a few hours. And I got this email saying, hey, Kevin, I'm having lunch. So his name is Carl Branson. He was the director of WARF for 20 years. We actually sadly lost him this past fall. But he had emailed me and said, I'm meeting a couple of friends for lunch, and I'd like you to join us because they have some questions about WARF history. And it turned out that he was talking with a professor of history of science and his predecessor, Dick Leeser, who was the prior director of WARF. And Dick was pitching the idea that somebody should write a book about WARF. And he was specifically talking about more recent history from basically since the Bayh-Dole Act, since 1980, and really the role that WARF played in passing the Bayh-Dole Act. And I don't really know why, but Dick kind of highballed the amount, I guess. Carl said, how much would you think it would cost to hire somebody to write a book like this? And Dick said, I don't know, kind of did some calculations in his head and say something like maybe $200,000. And Carl thought, I don't know that I could get my trustees to pay that much. And so the bell went off in my head of like, I'm a grad student. I don't need that much money. I could get by on much less than $200,000. I just need somebody to help me get through my dissertation. And at the time, I was trying to figure out what the dissertation was going to be. And so it took a couple of months of talking back and forth. And I found out later that I think Carl had always kind of thought maybe I could talk Kevin into doing this. But eventually the board of trustees hired me for much less than $200,000, let's just say, on a 3-year deal to write a book about WARF. And the original idea was that would pay the bills. I would write this book and turn it in, but it wasn't going to be my graduate studies. And then that ultimately started to evolve. And I figured out that there was really something here to write about. There was an academic topic that I could get a dissertation, an actual Ph.D. by writing about this.
So how many years has it been for you at WARF then?
So that summer I mentioned, that was the summer of 2011.
Okay.
And the lunch that we had, I think, was in 2012. And so it's been 12 years that I've worked at WARF. And so long story short, eventually I got hired on full-time by our communications staff. And so I've been at WARF 12 years in different capacities.
That's a great story. And I think that's also a good segue to dive a little bit deeper into the history of WARF, which I know was founded in 1925, and it had the first university tech transfer office. And you wrote about the founding of WARF in your thesis that was entitled Before the Foundation, Harry Steenbock and the Patenting of University Science, 1886 to 1925. You've told us a little bit about how you kind of got to where you are at WARF, but how did you end up choosing that topic for your thesis? It sounds like it started evolving out of that lunch.
Yes, and I can kind of pick up the story where I left off. So Carl has agreed to hire me to write this book, and the trustees have agreed, and I'm beginning to realize, well, first of all, I'm beginning to realize I can't write a book and a dissertation at the same time. There's going to have to be a choice here. And so do I take a break from grad school and write this book first? Or do I tell the trustees, sorry, I can't do this after all? That second one wasn't really an option for lots of reasons. But I was exploring this and trying to figure out, there was some hesitation about writing a dissertation about a place that I worked for. There's not a lot of objectivity there. Like, that's a certain question. And a couple of people had raised that in the history department. But I was asking around, and I went to a really prominent history professor in our department to pitch this idea to him. His name was Bill Cronin. He's a pretty famous historian. And he said, if you're going to do this, if you're going to write about the recent history of WARF, you're going to have to figure out what to say about Carl, because he's been a very important person in this town for a very long time. And pretty quickly, I thought, I wonder what happened in the early 20th century, because Carl's my mentor, and it was the idea of having to manage that and write about him brought a lot of questions up. But also, I wasn't trained as a sociologist. I wasn't trained as somebody. I was trained as an historian. So, and Bill's guidance was basically like, figure out a way to do this that draws upon your training, as opposed to trying to reinvent the wheel in the middle of a grad program. And so I started looking back at the beginning. I started looking back further, and the benefit is that WARF has been around 100 years. So there's lots of things to choose from. I think that's also just the way historians think, is like, well, if you're going to, you start at the beginning, go back as far as you can. And it really took me all the way back to the 19th century. And I started to realize there's an interesting historical story here. And that there's a lot been written about the Bayh-Dole Act by economists and education scholars and sociologists and some historians. And I wouldn't deny the importance of the Bayh-Dole Act. I think it's really important in shaping what we now call the tech transfer industry. But it's pretty clear that if WARF was founded in 1925, something else was going on. And so I needed to figure out, what was it about 1925? What was it about Wisconsin? Why is it Wisconsin? Wasn't it Stanford or MIT that had this first tech transfer office? And so I started looking around, and what I discovered was that there were a number of other institutions that were doing somewhat similar things, that they were kind of realizing, okay, we have these universities that are conducting research. There are commercial applications coming out of this. There's possibilities. There's also, so in the 1920s, you're also talking about a time that's after World War I, in which during wartime, the government was spending a lot of money on things like research, not as much as they did in World War II, but there's a similar kind of story as World War II, and that there's a lot of government funding going into the war effort. When the war ends, they pull all of that money back. And so it's the 1920s. It's the era of laissez-faire. Big business is ascendant, and government funding is being cut. And so a lot of people are thinking, well, how can universities find these other funding streams? How can we deal with this? And so there are a couple other places that were toying with these ideas. The two most successful, one was what was called the Research Corporation of New York, which was actually, it was incorporated in New York for various legal reasons, but it was actually coming out of the University of California, and an engineering professor called Frederick Cottrell. And what he really created was a contract research organization. And so that was also one of the bigger successes in terms of commercializing university research. The other one was in Toronto in Canada, which they had developed insulin there and had then contracted with Eli Lilly to develop insulin. And so that was a single invention. So you had these two options. One was a contract research organization that worked with multiple different institutions, not just universities, but other research institutions, and a single university that was working on a single invention, and they had a committee around it. And there were other places. Columbia had tried a patenting committee. California tried its own patenting committee with a different invention later. The Mayo Clinic in Minnesota, University of Minnesota, had both tried some things. And none of it had really taken off other than just this single invention about insulin and this research corporation. And so that was the context I was looking at. And that was when I really realized, okay, there's certainly a historical story here that hasn't been written enough that I'm trying to piece together. And I need to figure out how I'm going to intervene in that and how am I going to shape this for myself in a way that is really not just Bill, but my other advisors had said, you can't start from scratch. You got to draw upon what you already know. And so that's how I got to this earlier time.
And I've been through your thesis. It's quite excellent. And I think one of the things I found particularly interesting is, Wisconsin, the university is more of an agricultural school. And this whole story about patenting is tied up in the history of the discovery of vitamins. And maybe you can tell us a little bit about that and how that led to Harry Steenbock and the patenting of his inventions.
For sure. So one of the things I noticed, and it was really a conclusion I ended up coming to at the end of my research, was that you had places that were, so Columbia, Toronto was doing insulin, and that was a pediatric research foundation. Columbia had some pediatricians who were working on some vitamin-related technologies, and most of these other technologies, they tend to be from doctors, like medical doctors. And there were similar things happening in Austria and in Europe that are talking about vitamins from this, how do you treat patients, and particularly children. What makes Wisconsin different is that it grew out of the Morrill Land-Grant Act. There's a College of Agriculture that was founded in Wisconsin based off of the Morrill Land-Grant Act, which was passed during the Civil War. And so Wisconsin, unlike other states. So for instance, Michigan, you have Michigan and you have Michigan State. Michigan was founded when Michigan was founded as a state to be the flagship university. And then Michigan State was created as an agricultural college based off of the Morrill Land-Grant Act, which funded agricultural and mechanical schools. Wisconsin, for various historical reasons, ended up both of those universities are on the same place. So you have a letters and science college on one side of campus and an agricultural college on the other side of campus. And it was really that combination where you have both of those things happening at the same time that led to people on the campus who were thinking about things in different ways. And so as an example of this, you had Stephen Babcock, who was a famous name around here. We have Babcock ice cream named after him. There's a couple other, and if you've ever come, I highly recommend sitting on the terrace and getting some Babcock ice cream. And so most of the students today know Babcock for that reason. But the reason why he's the type of person you name things after was because he really was, I wouldn't say single-handedly, but he made two breakthroughs which made Wisconsin the dairy state. And his story was that, so he was trained in Germany and this is to give you some context for the time. This is the late 19th century. So in the 1890s is when he's coming to Wisconsin, is really the first professor of agricultural chemistry on the Wisconsin campus. But he's trained in Germany and trained in New York. So he grows up on a farm and then goes off to Germany as trained. And that's a pretty common story in the United States at that time because we didn't have German universities. We were still going to Europe to go to the big universities. And so there are two things. One is, so he's thinking in farm terms. He's hired by an agricultural college, but he has this really sophisticated training. So it goes back to that story, like Wisconsin has both the philosophical science and the applied science happening on the same campus. And the theory in Europe was that all you need for a nutritious, healthy diet are what we call macronutrients. So carbohydrates, fats, and sodium, and a little bit of salt. And that's all you need. And there was a guy named William Atwater in the United States who had adopted that theory. And so you have this transatlantic consensus that's what nutrition means. And Babcock said, well, I grew up on a farm. I could doctor some cow dung that had carbohydrates, fats, and proteins in it. I'm not going to feed that to my cow. I know what's going to happen to my cow if I feed cow dung to it. So this just didn't track. And so he conceived of this experiment in which he would test out that theory and do exactly what he said. And maybe not cow dung, but certainly he could take things and basically say, I'm going to feed an animal that would just have macronutrients and show you that that's not healthy. The problem is that the agricultural folks on campus who were managing the cow herd and had a prize-winning cow herd and were just having a lot of success really convincing dairy farmers that this university was worth their political support, they weren't terribly interested in their cows dying.
Yeah, killing off their cows.
Yeah. And so Babcock tried it on a cow and it got very sick. And the herdsman went to the dean and just like, this guy can't kill my cows. And so the dean said, okay, I'm going to reassign you to this project called the butterfat test. which is going to be basically a cylinder that will allow farmers on their own farm to determine the fat content of their milk. And what this did was that rather than going to a wholesaler and watering down your milk and pretending that it's whole milk, you could have a test right there that would test it. And so there's a famous dairy guy in Wisconsin who basically said that the Babcock butterfat test made more people honest than the Bible because it rationalized the dairy industry. And so that was his big breakthrough. And we have, that's why Babcock ice cream is named Babcock ice cream, is because he invented the butterfat test. He also developed what was called the cold curing of cheese, which is that you could cure cheese without high temperatures. And this being Wisconsin and it being winter, made it a lot easier to make cheese here. So those two things happened and they created a dairy state. So fast forward 30 years to, 20 years to the 1910s. And one of Babcock's students is a guy named E.B. Hart. And one of E.B. Hart's students is a guy named Harry Steenbock, who I wrote about. And 20 years later, the political support of the farmers was stronger. The university had matured, had grown. And the idea of using cows as experimental animals was more secure. They built a giant dairy barn, which had kind of shown people, like, if we do science here, and also the Babcock test had created this situation where the dairy farmers thought, well, science can be our friend. Science can actually help us and make us better at this. So we really loved the university. And so they devised, so E.B. Hart, inspired by Babcock and employing Steenbock as one of his graduate students, devises this experiment called the single grain ration experiment, which is we're going to doctor different grains. So a single grain, we're going to take one grain of corn, not a single grain of corn, but we're going to feed an animal one grain. We're going to feed them corn, and we're going to doctor the corn so that it has exactly the same amount of sugar, fats, proteins, and carbohydrates as a grain of wheat. And so we're going to have some cows we're going to feed wheat, some we're going to feed corn, some we're going to feed oats. But we're going to make sure that they're getting the same amount of the macronutrients. And what they found was what Babcock suspected, which is that some of the cows went blind. Some of them had stillborn calves. Some of them just died. And it turned out that the most successful grain was corn. And that proved that there was something other than these macronutrients. It was something originally they were called accessory factors. And then they came to be called vitamins. And there's a whole other story that we probably don't have time to get into about where the word vitamin comes from.
So Kevin, given all this, why was it so important for you to focus on Dr. Steenbock?
So as I mentioned, I had a certain background in humanities, and really the history of ideas was my focus, or what we call intellectual history, which is why do people think the things they think and what influence do they have? And I'd also written some biography. And so there was an instrumental reason, which is that I might not have a law degree to write about patent law. I might not have a scientific background to really understand deeply biochemistry, but I know ideas. And if I focus on one person and his ideas, then I can tease out why did this happen. And it gave me just a sense of focus as to where to start here. The other part is that Steenbock, after that experiment, goes on to be the inventor who files a patent that becomes the basis for the creation of WARF. And so he's a pretty central person to this story. And so really what I ended up doing was, and originally I thought, okay, I need to narrow my focus from this 100-year history of WARF. I write about biographies, I write about ideas, I'll pick one guy. And then I'll focus on this really interesting question of like, well, why did he patent? Where did he get this idea from? And some of it we've already alluded to is he grew up on a farm. He attended an agricultural college. And so he's not thinking in terms of medicine and in terms of theory. He's thinking in terms of helping dairy farmers. That's the tradition that he's been born into. And so focusing on him allowed me to really tease all of that out and really focus on questions of identity and where he came from.
Kevin, that's an absolutely fascinating story, but why does it even matter?
There's a number of different things. One of the advantages of focusing on a single person is that you can really tease out a lot of the complexity of just human life and human stories and those relationships. And so I was able to, as I said, determine that, okay, he grew up on a farm. That shaped his ideas. That shaped why he thought about things the way that he did. It also, I could dig into things like privilege, like why was it that a white man from Wisconsin was the one who created this rather than, say, George Washington Carver, who was a famous patent holder. And one of the things I determined was that, well, Steenbock wasn't really, quote unquote, born white. He was born German. He spoke German only until he went to school and then was taught English. But because he had German heritage, he was able to become white. And so he's going to school as an undergrad and a grad student in the middle of World War I. And but because he's white and speaks English, he can kind of erase his German identity to a certain extent. And not entirely. He still will claim it in some ways and still talk about it. And there's an interview with his sister in which she says that she talks about that German heritage being very important to his sense of individuality and just the way he thinks about things. So that part's important. But so there's an interesting story to give people an example of how I kind of dug into these questions of identity. There was a scientist in the 1940s that WARF hired to run an insecticide laboratory. His name was George Keto, and very similar to Steenbock, he was born to an immigrant family. His parents were from Japan, and the same way that Steenbock's grandparents were from Germany. And I don't know exactly how much Japanese George Keto spoke and those kinds of things, but he was born in California. So like Steenbock, he was born to an immigrant family. He went to a public university, the flagship university in his state, UCLA. And he went to university at a time when the country of his family's origin was at war with the country of his birth. So Japan and the United States were at war in the same way that when Steenbock was going to school, Germany and the United States were at war. The difference is that George Keto couldn't pass as white. He was Japanese American, and those who know some of the history will know that Japanese Americans were interned during the Second World War, which is not to say that there wasn't trouble with German Americans during World War I, but it was a different kind of story. They were, we renamed hamburgers and we didn't talk about sauerkraut and those kinds of things, but there wasn't interning happening. It was a different kind of story, right? And so where Steenbock was able to embrace his tradition and learn this tradition and become this founding scientist of this great institution, George Keto was interned, and they actually had to sneak in. So he was an entomologist, and his advisor had to sneak in his insect samples into this internment camp so that he could finish his Ph.D. And then when he is being hired by WARF, Steenbock basically uses some stereotypical examples to think that, well, okay, this is a Japanese American scientist. They don't have a great reputation, and he tries to get WARF to not hire them. Thankfully, WARF did not listen, and they embraced George Keto and hired him, and he ran our insecticide laboratory for a number of years. But I think that comparison, there's two ways I would frame that. One is that there's a positive story in the fact that Steenbock had this privilege. He was in the right place at the right time. He was able to be educated in a tradition that allowed him to make a difference in the world. And then there's a negative part, which he was also in a position where he could exclude. And I think both of those parts of the story are important to tell.
So, Kevin, as we've alluded to a little bit so far in the podcast, Dr. Steenbock had a very controlling personality. But obviously, he couldn't do everything by himself. So given the nature of his personality, how did he handle that, and what did he do?
Yeah, so control, as with a lot of things, there's a good side and a bad side. I think the positive side is that he was an extraordinarily principled person. He had very high moral ideals, and he was pretty uncompromising. So that's one way of looking at control, is he was uncompromising. He was also stubborn. If he had an idea and he thought he was doing the right thing, he was going to follow through with it. And so that gave him a certain perseverance on the one hand that was, so for example, when he first had an idea to patent a particular discovery, it was actually related to vitamin A, and it was about concentrating vitamin A, and he wanted to patent it because he wanted to be able to control how it was used and which industries would use it. Particularly, he didn't want the margarine industry.
He did not like the margarine industry at all.
Yeah, and that was a collective identity question, because it's Wisconsin. And when I talk about this in Madison, around Wisconsin, I talk about margarine. People will tell me stories about how they used to have to drive to Illinois to buy margarine, and how people would dye their margarine yellow so that it would look like butter, and how it evolved over years. So eventually, Wisconsin bans dyes, that you can't trick people into thinking you're eating butter when you're eating margarine, right? And so there's this long history of that. And it goes back to that Babcock story that I was telling, which is that Wisconsin's the dairy state. The dairy farmers are very central to that industry. And so it's really Steenbock thinking through this. And, it's hard to tease out, like, as you said, he really didn't like the margarine industry. And it's hard to tease out how much of that is personal attitudes and personal opinions, and how much of that is just knowing that he works in a state where almost literally his salary depends on dairy farmers continuing to support the university.
Yeah, I would say in reading your thesis, it seemed like the latter. He seemed very loyal to the dairy industry.
And also astute in understanding the politics of universities, and understanding, like I said, in an almost literal sense, knowing where his bread is buttered.
Exactly.
That kind of thing. And that's also so we'll get into this more, but as the story of WARF unfolds, there's lots of disagreements over what should be done, what shouldn't be done. Should this organization be empowered to do what it wants to do? Should we be patenting science? All these kinds of things. But everybody in Steenbock's department, no matter how much they disagree with him on various things, they're all saying, well, okay, in this case, we really should patent this because we can't allow the dairy industry to be threatened. And so that's the one that there's consensus. And that's also the story that I think was told about WARF. People have written about WARF before me. That was really the bottom line. And I don't disagree with that. I think if it wasn't for this dairy question, the patent doesn't get filed, WARF doesn't get founded. But to your question about how Steenbock's controlling personality factors into this, what I started to realize was it wasn't just Steenbock's sort of personal sense of will. He wasn't the only person who mattered. I needed to figure out, okay, why did he patent? What was his motivation? But very quickly, you get into a story in which you realize he can't do this by himself. And so one of the central arguments of my dissertation is that Steenbock wanted his science to be controlled. And by the way, it wasn't just about the negativity of the negative motivation of preventing margarine from having this. It was also the positive motivation of doing something positive with his science, of not wanting to be a sellout, not wanting to just sell his invention to industry. He was a scientist. He wanted his science to be used well. He wanted it to be scientifically rigorous. He wanted to maintain control so that he wouldn't have industrial people coming along and lying about his invention or misusing it or mistreating it, those kinds of things. So both of those things are kind of tied together. But very quickly, in order for that goal to be realized, which is the use of his invention will be consistent with his principles, consistent with his political interests, and consistent with his loyalty to his home state, he needed help. And so that's really where it started. So I think I'll just kind of walk through the story. So as I mentioned, he was trained in the single grain ration experiment, which discovered vitamins. And so then that sets the course of his career. He becomes a vitamin scientist. And in particular, there are some vitamins that dissolve in fat. There are some vitamins that dissolve in water. And so he was really a specialist in fat soluble vitamins, which we now know as vitamin A and vitamin D. And then there's the water-soluble ones, which are vitamin B and vitamin C. And then there's other vitamins from there. But at the time, they were just fat-soluble and water-soluble. And he's in the middle. He's a scientist during the time when they're teasing out that, vitamin A and vitamin D are actually two separate things. We thought they were one thing. And so he's one of the scientists who's figuring this all out. And he's also within this global transatlantic conversation. So as I mentioned, there are people at Columbia working on vitamins. There are people in Austria who are helping children in post-war Vienna and trying to figure out how do we cure them of rickets. There are people in Great Britain who are figuring out that if you feed Scottish oatmeal to children, they have weaker teeth. There's all these people. So it's a global conversation that he's intervening in. That's the first place where he's not doing this by himself. It really is a collective enterprise. And it really is, as it is today, scientists talking to each other. That's where innovations come from. And so he comes up then with this process where he can figure out that, okay, so first of all, he figures out that like the yellow in corn is part of where the vitamin content comes from. So he has this interesting stuff he's writing about the color yellow and its association with vitamins. But he also figures out that there are certain vegetables that have vitamin A in them, and he can concentrate the vitamin A into a form, and very similar to what we would call now a vitamin supplement or vitamin capsule, he can concentrate that into vitamin A. And that's when he first realizes, well, butter has vitamin A in it. Margarine doesn't necessarily. And so if you can create a vitamin A fortified margarine, it would compete with butter. And that's his original concern. And he says, well, how can I prevent this from happening? How can I allow the dairy industry to get first shot at this? Well, I'll file a patent. And he later admitted that he'd never really seen a patent before, has no patent expertise, doesn't know how to do that. He also is not really interested in being an entrepreneur. That's not really his goal. He's not interested in some of these other people around this time who are toying with patents. And I mentioned Columbia and Minnesota and the Research Corporation. They all do have this entrepreneurial mindset where they kind of see there's an opportunity for me to work with industry. There's an opportunity for me to create a business. That's not what Steenbock is about. He really is more about this scientific principle and scientific control. And so he goes to university and he says, well, will you do this for me? I think this is in the university's best interest. I don't think this is just about me being from Wisconsin. This is really in the interest of the university. And the university, it's hard to find out exactly what they said to him because they basically said nothing at all. They kind of ignore him. And eventually they say, okay, fine, we'll hire a lawyer, whatever, we'll do it. And then the lawyer goes off and doesn't really do anything because nobody's really paying him. Nobody's really working with him. And the patent application just sits there and eventually it expires. It's up for a long time. Yeah. And nothing happened for over a year, I believe it was. Yeah. Close to 2 years, I think even, but somewhere around there. Yeah. And in the meantime, Steenbock finds that he gets a letter from a guy who's working at Carnegie Mellon who basically says, oh, you're doing this vitamin research. Tell me about it. And Steenbock writes back to him and says, here's what I'm doing, concentrated vitamin A. Here's how you do it. Here's my tips. And then he finds a notice in a local journal, and it's sitting in his paper, circled in his blue pencil, in which the guy who wrote him had been given a fellowship from Swift Margarine Company. And so Steenbock says, oh, great, my lawyer's just sitting on this application, and now I'm pretty sure this guy is going to go give this to the margarine company. So and just kind of throws up his hands. And so that's kind of this negative experience. But Steenbock, being who he is, doesn't give up. He's a very pugnacious, stubborn type of a person.
Definitely.
And as he put it in his document writing the story, he said, in the meantime, another matter came up. And what had happened was they'd figured out that vitamin A and vitamin D were two separate substances. And he was reading all of these documents, and he realized that people were hypothesizing about how vitamin D worked. And so just to give people the basics, as a lot of people will know, if you go out in the sun rays hit your skin, and that creates vitamin D in your skin. There's something happening there. The interaction of the sunlight, of the UV rays, and the fat in your skin gives you vitamin D. And the people in Vienna were figuring this out as well. If you put children out on a balcony, they can be cured by rickets because they're having sunlight. They also had experimental results that showed cod liver oil had the same results. And so we now know that what's happening is that cod, the sun hits the water and penetrates the cod. And because cod are oily fish, that oil reacts with the sunlight and creates vitamin D. But this was kind of a puzzle, which is, okay, eating cod liver oil and getting out in the sun, what's the connection? And they're trying to figure that out. And at the Lister Institute, which is a British institute that was working in Austria, they had published a couple of papers in which they hypothesized that they had a couple of rats that one rat had been put under a sun lamp, one rat had been left in its cage. And when they put those two rats back into the same cage, both of them were protected against rickets. And rickets is the disease you get without vitamin D. So basically, neither of these rats got rickets. Something's happening here, that both of these rats are getting vitamin D. And they said, we don't really know what's happening, but maybe the ultraviolet lamp is charging the rat with some sort of electrical charge, and that electrical charge is jumping from one rat to the next. Or, maybe it's something about the glass that we're putting him in, something like that. But basically the hypothesis is that there's an electrical charge that's transferring vitamin D. And Steenbock and his students read that and they think that just doesn't make any sense. That's just not how, we're farmers. We come from a farming state. We're in an agricultural school. This isn't really how animals work. This is kind of puzzling to us. And so Steenbock then sets up a very careful experiment in which what he hypothesizes that what's really happening is that these rats are eating the refuse at the bottom of the cage, that there's probably sawdust in the cage and it's probably eating that sawdust. And so they set up a two-tiered cage in which there's mesh on the top floor, and they put the rats on the top, and then all the sawdust falls through. And they try the experiment one time and they get the same results. Both rats, the rat that has been under the lamp and the rat that has not been under the lamp, they both seem protected. Neither of them get rickets. But he doesn't give up. Again, this is a common story. Steenbock just kind of keeps doing what he's going to do and keeps thinking about it. And they realize, the screen that these rats are walking on at the top layer is greasy. What if we clean the screen? And so they clean the screen very carefully in between. And then the rat that has not been under the lamp does get rickets. And so this is evidence that they're ingesting something. And so the connection Steenbock makes is that, what if we take the food directly and put the food under the sun lamp and then feed the food to the rats? And that experiment has positive results, and they publish those results. And at the bottom of the first page of that article that they publish, it says the results of this paper are in the process of being patented by the University of Wisconsin. And so that's his discovery. And so I think that's also tells you why the character of Steenbock is important, is because it's not that he's, Isaac Newton looking at an apple tree or, Albert Einstein writing on a chalkboard. This is a very careful, instrumental, stubborn scientist who makes this breakthrough.
So how did all this lead then to the creation of WARF? Because he had gone to the trustees, wanted a patent. They were kind of like, they never answered him. So how did he end up getting his patent? And then ultimately, how did that lead to the formation of WARF?
Yes. And so this is the part where Steenbock needed friends. He needed help. And so the first thing he does is he says, well, I'm going to just fund the patents myself this time. I've got this separate vitamin D discovery. It really didn't work out with this vitamin A thing. So I'm just going to do this myself out of my own money. I'm going to go find a patent lawyer. It happens to be a patent lawyer that's an alumni of the University of Wisconsin. And so he's just going to say, I'm just going to go do this, and I'm going to trust the university will figure it out later. That's one key thing is Steenbock's stubbornness. But the other thing is that this time around, it's not margarine companies that are interested. It's the Quaker Oats company. Because as I mentioned before, oatmeal is connected to weak teeth and weak bones. And the Quaker Oats company is nervous about this. And it's as much a marketing problem as anything, because there's science out there that basically says oatmeal is bad for you. And they want to figure out a way. So, okay, this guy has vitamin D. Vitamin D prevents weak bones. It prevents rickets. We're interested. And so at some point they go to Steenbock and say, we're going to buy this off of you. But it's important to note that the reason why Quaker is aware of Steenbock is not just because they're up to speed on their scientific journals. It's that they have a farm in Madison, Wisconsin, and they have scientists that are there. And there's a scientist actually named Carl Miner, who is a consulting chemist for them, who has been working at a place called the Forest Products Laboratory, which looking out my window at WARF, I can see the Forest Products Laboratory right now. And what he does at the Forest Product Laboratory is figure out that if you take a bunch of leftover oatmeal hulls, so the refuse from making oatmeal, there's holes on the ground, and Quaker says, go figure out something to do with this. And he uses the equipment at the Forest Products Laboratory to distill those holes down into a chemical called furfural. And he becomes the father of furfural chemistry, and so Quaker Oats basically has a monopoly on this chemical called furfural. And while Carl Miner is working in Madison, he becomes friends with Steenbock. And so Quaker has these connections. They know about this. They're working with his farm in Madison, and they know that there's this science that's happening that might benefit them. They go to Steenbock and they say, we'll buy this from you. And Steenbock says, that's not really what I'm in this for. I'm not in it for the money. I'm not trying to make money off of this. I just want to make sure that the interests of my home state are protected and that the science is used the way that I want it to be used. And so he basically turns them down. And that's when Carl Miner, and we don't know exactly who told whom to what, if Steenbock told Miner, if Quaker told Miner, whatever, but Miner says, I was reading this engineering journal and there was this proposal in it that talked about a corporation founded by friends of the university, who would not have any official connection to the university, but they would create this separate corporation that would be nonprofit, and it would license patents, and it would basically do what the research corporation does, although Steenbock didn't know about the research corporation at the time. But it would be attached to university, and then any money they made, they could donate it back to university. And this becomes the idea that becomes WARF. And so then you have this idea. And then what's happening in the meantime with that is that Steenbock has two college deans who are administrators. And unlike Steenbock, they understand how universities work. They understand the bureaucracy. Steenbock understood the politics of dairy farmers and that kind of thing, but he had never run a department or run a college. And he's not really interested in being an administrator. And so the dean of his college is a guy named Harry Russell, who was a collaborator with Stephen Babcock back in the 1890s. And in the meantime, had built the College of Agriculture by doing things like finding corporate funding. He was the one who had arranged the relationship with Quaker and had brought them there, and had created different funding relationships and industry sponsorships. And so Russell finds out that Quaker is interested in this, and he sees an opportunity here to help fund his college. He basically says, as in one of the letters he wrote, he said, science is getting more and more complicated. It's getting more expensive to get at the gold, to dig out the gold from the ore. We need something to help us with this. And we think there might be an opportunity here. He also just has the acumen to negotiate contracts with a company like Quaker and to make this work. So what he does is he introduces Steenbock to a guy named Charles Slichter, who's the graduate dean. Charles Slichter has these alumni relationships. And so Russell and Slichter together persuade the Board of Regents of Wisconsin to allow the creation of this foundation, and Slichter goes off and recruits the alumni. And so those are the three pieces together. That's kind of a complicated story, but I think the three pieces are Steenbock being stubborn, Quaker being financially interested, and the university having the administrative capacity to deal with this. And I think that's something that tech transfer offices today will recognize. If you have any patent, you need those things. You need a scientist who's doing good science. You need a commercial interest, and you need a university that has the structure to actually handle the process. And that's where WARF came from.
Well, Kevin, I think that's a great place to stop this week. And that brings us to the end of part 1 of this series on the history of tech transfer. From the early patenting efforts of universities to the founding of WARF, we've explored the fascinating origins of this field with the help of our guest, Kevin Walters. But this is just the beginning. Be sure to tune in next week. We'll be diving deeper into the story and tackling more big questions, such as why WARF succeeded where others failed, what happened to the Steenbock patents, and how the post-World War II environment led to the passage of the Bayh-Dole Act. So be sure to tune in next week for more insights and analysis on this fascinating topic. Thanks for listening, and we'll see you soon.
Thanks for listening to Autumn on the Air with Lisa Mueller. Get social with us and share your thoughts. You can tweet us at AUTM or visit us online at AUTM.net. We'll be back next week on the air. Be sure to join us.
New to tech transfer or a seasoned pro? Autumn is the global member organization for tech transfer. and is here to help you get connected, get smart, and get ahead. Whether you work in academia, research, government, business development, corporate engagement, or startups, Autumn is dedicated to supporting you through education, advocacy, networking, and promotion. Join and you'll receive 20 free live webinars, as well as meaningful discounts on meetings and courses, insider access to a vast network of colleagues to help you through challenges, and align on new technologies and the university decision makers who license them. Membership is open for 2023. Join us.